ये जो है
sample space को reduce.
Maybe some of you are here for the first time in this activity, but we started it last year. As a platform for sharing ideas. So we hope that many others will also contribute to this.
Awesome.
And the reason why this idea came to my mind was that each one of us in the faculty, we come across different problems and we sort out things either ourselves or by asking experts, but you don't expect that everyone else will go through the same process. So some ideas or concepts will be very obvious to you because you happen to be in that area, but for others it will be an uphill task. So, I mean, since we don't have regular interaction meetings, so I thought this could be one way of doing it. So, because I am aware of many misconceptions among students when I interact with students, so I thought, okay, let's start from those first, and then later on others could join. Today's workshop is very basic. I think I should have started it last year as the first workshop, but this didn't come to me at that point. And this is about concepts themselves. So the name concept sharing workshop. So and by concept I mean that how do we represent reality in our mind? Because it's all about the human mind. So knowledge is in the human mind. It's not real. So what is real, we don't know. We don't know the actual nature of things around us. But we do have some mental picture of reality. And that, so many people misunderstand. They think that the way we perceive reality, the reality is that way, but it is not true. Because we have limited channels to perceive reality. And we don't even know how nature plays with us. Maybe we are being tricked somehow. So, and I will start with the very first attempt of humans, and it starts from your childhood. When you give names to things around, so like chair, table, tree. So if I list a few of them. We give these names and we think that this is the table, so this T-A-B-L-E, B-L-E is real. But the problem with this is that you do not teach a child the definition of a table. I mean, if I ask you or you ask me, I may not be able to define a table, but I am still able to distinguish a table from a chair. And children are capable of doing that. So you just show them a few tables, and then they can distinguish any table, no matter how unusual that table might be built. So what is it that helps us? So people have worked on this area. I mean, especially those who are working on psychology, how mind represents knowledge. And what they have, their research finding is that we only keep a mental picture of a few essential features of reality. So if I say this is a table, there are so many details which I am actually leaving. So I'm not interested in, I don't bother whether it's wood or whether it's steel or whether it's glass. And I don't care about these imperfections as well. Maybe the edges are not very straight. It is still, for me, it is still table. So that means that my mind will have some representation, and now I'll give that representation a name. I'm not giving that name, I mean, people have given that already. This is the first model. So that means that every name we give to something is a model. And it is just one type of, it's the most basic model. And to distinguish it from other models, because these are not the models which you are used to in engineering. They are more sophisticated. So to distinguish this model from those complicated models, you can think of these as conceptual models. So conceptual models are your first attempt to talk about reality. Because without these models, how will you communicate? Now, so to rephrase all what I said, I see these labels not as definitions, because a definition is is unique. When you say this is table, then only this is table. If a table is built in any other way, this will not be table. So you can think of this as a classification problem. So a table represents a class of objects in the real world. So when you look at things, you want to fit things in those classes. This is one way, or you can think of it from the other side, that you want to fit that model to real objects. And okay, if that model fits to this object, you say, okay, this is stable, and this is not, for example. Now, you have to understand that these, the definitions of these terms will always be fuzzy. So you cannot be exact. If you want to be exact, you will be in trouble. Because let's say the difference between a chair and a table is that extra thing in a chair, this elevation. But if I just put a strip on a table, I mean, if you are very precise, you can think this is, so you can build structures which could be declared as table as well as chairs. And although this discussion is very basic, but it can be, applied to many other concepts. So this fuzziness is always there, but we still somehow are able to deal with that. Now imagine if humanity was only relying on these fuzzy ideas, or only on conceptual models. So if I want to summarize these ideas, I can now say, that I have, in this circle, I have the real world and the objects in the real world. You also refer to it as a natural world or physical world, whatever name you give. But the way you perceive reality, or you talk about reality, you imagine about reality, you have a different word, and that you can now call it the conceptual world, the human mind. So each object here will have some model here, and these are conceptual models. So the object is mapped to a model, and this process, you can call this process conceptualization. When we conceptualize reality, this is what we do. The problem with this, do you think that the animals are also capable of this? Yeah. They will have other ways, but they must be able to do it, because without that, they cannot survive. They must be able to classify with their own, they will have their own conceptual models. So human race can, no living thing can survive without this. No. So you can even extend it to plants. Plants will also have some way of representing reality, and then it reacts to reality, responds to reality to survive. So now the problem is that if we rely on this only, then there will be no difference between humans and animals. Yeah. So so far there is no knowledge. What we call knowledge, science, technology, it cannot be built on this approach alone. You want a more sophisticated way of representing the real objects. The reason is that because these models are fuzzy, the definitions are fuzzy, vague, the human mind is capable of something else, and that cannot be applied to these fuzzy objects. And that is logic. We possess the capability of applying logical rules to things. The problem is that the logical rules are very simple, and they are very pure, they are abstract. So they also require simple objects to operate on. So if you apply logical rules on these fuzzy ideas, there is no direction. So over a period of time, humans, when they started contemplating deep about things, they came up with another way. So now you have a two-step process. This is for the layman. Anyone can do that. Yeah, because anyone can speak language. Speaking language is not something intellectual. But the intellectuals came up with another word. And in this word, any definition, any model, any object will be very well defined. There will be only one meaning of it. And this will transcend nationalities, languages. So no matter whether you are English or Spanish or Hindu or Muslim, doesn't matter. An object defined in this world will have only one meaning. And the advantage to that is that when you apply logic on those logical rules on those objects, you can then rely that things are going in the right direction. Because in the beginning, and I'll also tell you why this logic doesn't work here. Because the definitions are fuzzy, so most of the things are they appear to us as one package. Many things are actually mixed up. So I'll now give you an example before going into this. But I can still write the name. This is the formal word. And you also use it in language, formally and informally. And formal word relies on logic. And mathematics is a special branch of logic. Logic is more general. So there are some algorithms, like simulation, which is purely rule-based. There is no mathematics, there are no variables, no equations. There are simple rules. So you can say logic represents both. Simulation is also used as a term if you solve mathematical equations, but you know what I mean. Now, these activities require pure objects. So we will go one step further. We will represent the conceptual models with pure models. Mathematical model, you can call it mathematical model or formal model, or you can abstract model. Now, these models, if you look at the definitions, they will sound very funny because they will be very remote from reality. But the purpose of these models is not to copy reality, because in that sense these are better. The purpose is to have simple objects so that you can apply logic. And here, this is the point which many people miss. So they will always attack your theory. If you come up with any theory, they will attack, this is nonsense. Because they are not aware of this process. This is the only way. One other reason of these abstract models is that the human mind can only operate on one thing at a time. So we try to isolate things. And at this point, I want to give an example. One example, which is very obvious. So if I, for example, So how would you refer to this?
Triangle.
Triangle. Yeah. Triangle. And if you recall the definition of a triangle from school time, a triangle should have straight edges. Now there is no way you can have straight edges in reality. It's impossible to achieve. So no matter how careful you are, at the end of the day, you will reach the atomic limit and you will have atoms, and atoms will look like this. So, which means that there is no triangle in the real world. So this means that the idea of triangle, which was defined by Greeks, was not to copy reality. It was because they wanted a simple representation. So now I'll tell you whether an object which you will qualify as you will classify that object as a triangle. It can be made of gold, silver. Yeah. It can have straight edges. Apparently, it can have crooked edges. It can have different colors, red, blue, but you will still qualify that as a triangle. Now, this means that the name triangle is not a definition. This name is a conceptual model for the property called shape. So you decide that I am only interested in shape, because in some problems the shape will be important. So like imagine if you are plugging in different devices, yeah, and let's say if the slot is triangular, when the children play, and you can only fit a triangular shape. So there, in that problem, in that discussion, only the shape is important. The color is not important, the material is not important. So triangle is a word for shape, not for an object. And then once you understand this, that this is a model, yeah, so then you can say, okay, for me it's a triangle. It may be anything else. And one more thing, when I say triangle, the definition of a triangle has no color, no material, nothing, straight edges. Because I am deliberately ignoring every other detail, and I am not denying the reality of those. I do not want to say that there is no color. The real objects will have color, but that having or not color or not having it is not relevant to my investigation. This is the most important thing. Many students think, and because we are taught that way, that I am somehow denying reality. But now flip this argument. So I gave you one example where the shape matters. So shape is the only consideration for you, so you ignore everything else. Now let's say that there is another situation where some group of children will be attracted to red color, or birds will be attracted to red color or green color. There you will not be interested in the shape. So for simplicity, you could say, okay, I assume that all the objects are circular. Because whether you assume circular or triangular is not the point there, because their color matters. So when you say red, now can you define red? I can't. I don't think anyone can define red. Because red is a conceptual model where you are focusing on some property and you ignore everything else. Now that does not mean that everything else is not existent. So now these are very school examples. I will now give you a little, an example which looks scientific, and that is the Newton's law and the Coulomb's law. In both, and they are both related to the idea of point. Like in geometry, you have these concepts like straight line. Now straight line. So when Euclid defined straight lines, we might think that he somehow came up with this idea. No, they were dealing with real ropes, which look very complicated. So they were using ropes to measure areas. Yeah. So if you want to calculate the area of a field, you will have a rope. Now, if Euclid was using real ropes, why he defined a line as something with zero thickness. It sounds contradictory. He had no roof with zero thickness. The reason is that the thickness of the roof was not playing any role. So he did not deny the existence of thickness. It only simplified the discussion. Because at that, as far as measuring areas is concerned, you can have a conceptual model, straight line, with no rope is straight and no rope has zero thickness. But now, again, I want to also mention that this conceptual model is only valid in that discussion. Don't try to apply this to every situation. So let's say you are a trainer and you are training scouts, Boy Scouts, how to use ropes to tie, for example, and to build fences, things like that. They must be capable of distinguishing a good rope from a bad rope, the thick one and the strong one, and how the knots are arranged. Yeah. There you cannot use the model of straight line. Yeah. So conceptual model has its domain of application. And only for that, if you are convinced that any piece of reality, any properties which do not play any role, you just ignore it. So similarly to straight line, there is another concept, point. Now if you go back and recall those definitions of point has no thickness, no length, no width, no height. Now you cannot show me a point. It's not real. So what is it that we are looking for which forces us to define this weird, unreal idea? Position. If your goal is to locate things, now if I want to say that this camera is here, I am interested in the position. I am not interested in the dimensions or size or shape. Whether it's rectangular or circular or this much or that much is not my point. All I want to see is where it is located. So if position is the property you are looking for, your conceptual model will be point. So you will attach a point to everything. Although all those things will not be of zero dimensions. And this is exactly what these guys, Newton and Coulomb, you know both of these laws. So if I write Newton's law, I think there are two laws. The Newton's law of gravitation, m1, m2, by distance squared and some constant, the force between the 2 points. And the Coulomb's law is the two charges getting multiplied r squared. Now let's try to interpret these equations. So this is the force and this is the force. By definition, if you go back, these are point masses. Point masses mean that the masses have no dimensions. And yet the same Newton applied this law to planets. Now planets have mass, they have dimensions. I mean, think about the radius of Earth. So his point was to locate the Earth in the space, and to locate, let's say, Sun in space. And when is the dimension of Earth or Sun or planets not playing any role? When the distance involved is much, much larger. Only then it will matter. If you are inside Earth and you are, let's say, involved in some activity, you will not say the Earth has zero dimension. One other thing is that, and the same goes for charges. Even electrons have dimensions. So they are not point charges. One last example in this, and then we go to the next topic. If you are aware of this law, again, the mass here is a point mass. But yet we apply in in equation, in physics problems, we apply this to cars, to balls. They are not zero dimensional. And there are two requirements. Not only should the object size be negligible compared to the distances involved, this is one, but there is another requirement as well. The object must be rigid. So if it is flexible and if it is like, you will not apply this to a spring. So if you throw a spring, you will not apply this law to that. Because the shape is changing and potential energy is also playing a role. In this case, only kinetic energy will play a role. So, I mean, I'm not teaching physics to you. This is not the point. The point is that every conceptual model will have some reason behind it. And I would like that once you, I mean, I would not say that you are learning this for the first time. We are aware of these things, but I'm just highlighting it. So if you realize that we are already doing this, so it would be better to make your students also aware of that, so that they do not confuse models with reality. Because we are doing it so often that we forget that these are models. We think that they represent reality in entirety. So now coming back to this point, these are now examples, this equation, this equation, this equation. These are now examples of rules of logic. Because any mathematical equation or any algorithm is a rule of logic. Now, rule of logic is pure. It's very abstract. So it will also require pure objects. So now, to have a definition of point mass or something, it will be a two-step process. In the first step, you will represent reality with a conceptual model, and that will be a vague thing. But then you will refine it further. So this definition of point mass is not a conceptual model anymore. Because now you have given a well-defined model, zero dimensions. Here you do not say zero dimension. Here you only say, oh, I'm only interested in the position. You are not denying reality, but here you deliberately remove everything. And that is why those objects, they are abstract, because they have no counterpart. So, and this step was called conceptualization. This step is called abstraction. Abstraction, or you can say idealization is also a better word. Because you idealize things, you make them ideal. Now, this ideal should not be confused, because this idealization is in a very narrow scope, also used in engineering in another context. And I must clarify that. So in engineering, there are some, like you are aware of this Carnot cycle. Even if you forget the details, this is an engine, a theoretical engine, to which every other engine must. So all the manufacturers are in a race to reach the efficiency of a Carnot engine. And they know they can't. But everyone wants to be as close as possible. Now there the idea of ideal is different. It represents the perfect or the most efficient thing on earth. Yeah. Here, the way I use idealization here has a different meaning. Here, the idealization is not to make it like desirable, but to be able to work with it using logic, rules of logic. So this ideal and that ideal, they are different.
Reduction, simplification का मतलब
हाँ, simplification, give me simplification. Idealization, abstraction, simplification, different words. Formulation. So I think maybe if these examples sound too mechanical, maybe I should give one or two electrical examples. Because it's also human psychology that you may find this very easy to identify that they are models, because you are not mechanical engineers. You are electrical engineers, so if I now talk about electrical ideas, they are so well cemented in your brains that it will be very difficult to undo those beliefs. So for a mechanical engineer, it will be very difficult to believe that it's a point mass, because he's so used to applying these equations, these or these. So let's talk about another object we use. Let me place it here. It's actually here. So let's say here you come across, usually if you go to a lab, an electronics lab or circuits lab, and you come across some cylindrical shape with these bar cords and two terminals, you immediately say, oh, it's a resistor. Yeah. So you here, in the conceptual world, you have a name for it, and you say it is resistor. And when you say resistor here, you're not defining it. You, at that point, you are not very precise. You say, okay, it's a resistor because it will resistor current and two terminals and some very, you will talk qualitatively. But once you bring this conceptual model here, and when you write R, this R will have only one meaning. Because here, what you have in mind is not the thing. What you have in mind, because you see here, everything is driven by logic. What you have is Ohm's law. A straight line with a slope 1 by R. So now compare it with the discussion of shape, color. Here, you are interested in this behavior. So as long as something is close to this behavior, you classify it as a resistor. But the same thing for a geometer will be a cylinder. He is not interested in Ohm's law. A chemist, a chemical engineer or chemical scientist will be interested in its composition. He will be interested in whether it can get rusted or not. Yeah. I mean, everyone will have his own conceptual model and then a mathematical model. So now, I mean, it's very clear that the reality is much more complicated than we think. Reality comes as a complete package. And because of the limitations of our human mind, we try to isolate things. And then the same us sometimes believe that my mental picture is the perfect one, and then we argue with each other, okay, it's rubbish. So I also would like to get a bit humble about what we are doing, because we are doing a very limited activity. So, and even for an electrical engineer, the same real object can also be, I mean, if you are interested in the magnetic field, you will say, okay, it has some inductance. And then, if it's interaction with Earth or with any other object, if you focus on the electric field, then you can attach capacitance to it. And even there, use, like for example, if you see a spring, in the conceptual world, you attach first resistance to it and then inductance. And there, in the mathematical world, you do something like that. Now, what is this? We are placing things in series, and maybe sometimes you do it in parallel. But it's all your mind. Nature does not care about you. Nature has everything together. So these are only approximations. The only way you will evaluate or validate these approximations is once we make this abstraction, apply rules of logic, do some calculation, simulation, mathematical, anything. At the end, you will come up with some conclusion, and that conclusion will be tested experimentally back. So you will have to first you will have to undo this abstraction, and this is the phase we call this interpretation. So many people are very happy to program, to solve equations, and they just love it. They enjoy it. Some people enjoy mathematics, some people enjoy programming, and they want to see those plots. But then, this is the most boring part for most. But if we don't do this, then this whole thing is rubbish. What was the point? So you must do this. You must interpret each and every term at the end, each and every plot you see. And even that is not enough, because you are not now only in the conceptual world. You have made sense of the equations, of the solution, of the values, of the plot. Then there is the last phase. So at this point, you don't know whether all this exercise was useful or valid or. Then you will have to design experiments to validate your claims. So, till this point, you only have claims. Conceptual claims and mathematical claims. So, it is only at this point you can call this step as validation or evaluation or verification. Only now can you say that, okay, this was a useful exercise. Although I was dealing with purely abstract things, reality is not like that. You can argue with me. And many people, they enjoy these discussions. Oh, why do you have it in series? Forget about those arguments. Just wait till this point. So even to this day, many people are actually bashing at Einstein at his assumptions. Oh, how can the speed of light be constant? Even now you will see people. But his predictions are working. He was successful at this stage. So no matter how unusual his assumptions might look like, no matter how stupid they might sound, he is the winner. That's science. So you could come up with a very convincing argument. Everybody will be agreeing with you. Wow. But at the end, what you predict will have nothing to do with reality. So we should also learn how to appreciate science by its ability to predict things, not by whether we are convinced or not. The same is true happening with quantum mechanics. Many people dismiss quantum mechanics because it looks very weird, probabilities and randomness. So for example, when you hear this idea that an electron is a wave, I mean, I myself find it very unusual and difficult to believe. But without that, if you model it as a particle, you can't. So modern electronics, I mean, Rashid Karim will share that with you. All these models in VLSI, they are based on quantum mechanics. Classical physics fails there, especially when you come down to these small devices. When you squeeze transistors closer and closer, the classical physics simply fails. But it is convincing. So science does not care whether we are convinced or not. So I hope I could. So maybe to repeat, this is the first step: conceptualization, abstraction, abstract objects, then rules of logic, mathematics, simulation, conclusion, interpretation, and then validation. So I think now you can remind me if you have any. Because maybe I did not give enough examples. So if you can somehow relate other examples to this, we can now, or any disagreement, for example.
ये जो प्रोसेस है पूरा एक कंप्लीट प्रोसेस है, लेकिन ज़रूरी नहीं है कि ये प्रोसेस उस वक्त आपके पास आ जाए जबकि आप उस चीज़ को हार्नेस कर रहे हो या काम कर रहे हो.
हाँ, ये तो बिल्कुल, ये तो नहीं है, ये तो ज़रूरी नहीं है.
क्योंकि एबिलिटी फॉर एग्जांपल टू ड्राइव ए कार,
हाँ बिल्कुल,
वो तो अलग चीज़ है, और जानना कि इंजन में एग्जैक्टली क्या हो रहा है
बिल्कुल,
वो एक सेपरेट चीज़ है.
बिल्कुल.
तो यू कैन हार्नेस ए सोर्स ऑफ एनर्जी फॉर.
लेकिन इंजन को इम्प्रूव करना, टू इंक्रीज इट्स एफिशिएंसी, to bring more features into it will require that knowledge.
फ्यूल इकोनॉमी या कोई अल्टीमेटली
ये है.
द बेस्ट पे चले जाना.
और ये अच्छा है आपने पॉइंट आउट किया. बहुत सारी एग्जांपल्स ऐसी हैं. मैं आपको दो एग्जांपल्स दूंगा जो कि बिल्कुल अपोजिट है. Most of the times in history it happened that the experimental activity was always ahead of the theoretical activity. So like Faraday, he discovered electricity and he himself had no clue of how it worked. He could not explain it. And he was not shy. He shared it with the community. That I have these steps and I can light a bulb, but I don't know how it works. And it took 50 years for the scientific community to explain those things. The scientific community had to wait for Maxwell. Maxwell, I think, was a child when Faraday was doing it. So you see, but I can give you another example. Einstein. Einstein, when he gave his theory of relativity, you know why he was not given Nobel Prize for theory of relativity? We now celebrate him for theory of relativity, not for photoelectric effect. Why? Because at that time photoelectric effect was an experimental problem. And he explained that problem, so people they were able to understand his work. But what he had in mind about relativity, science, the technology was not ready to understand it. 50 to 60 years later, now all our communication systems, satellite communication, global positioning system, will fail without taking into account relativistic effects. So now we say, oh, he was a great scientist. And at that point, we didn't even bother to honor him for that. So you see, so these steps, don't expect that you will see all these steps in one generation. But at least you should be aware of it. And you need to know the importance of each and every step. Now, what I have observed, if I now map, this is a very unfortunate fact, and especially in Pakistan. If this axis represents different people, scientists or students or teachers, I will have two clusters. In one cluster you will find math geeks. They will love to talk about math, solving equations, and then they just enjoy the stuff. And there is another group. They are tech geeks. They enjoy working with devices without even a slight attempt to understand it. They don't try to understand what is going on. And both these groups are somehow, I would say, slaves of their desire to impress people. Because if you fall into this trap, you will excel in those activities which help you to impress others. And that will be at the cost of your own learning. You will stop learning. And this will happen to both these. So what I request you to be here. So I don't like this and I don't like this. So you should know what you are doing. You should know why you are doing. But you should also get things done. So, I mean, imagine if the rest of the world, like Europeans and Americans, if they were also in these two groups, how would science be fair? We will either have people like Greeks, philosophers arguing with each other, مناظرے کر رہے ہوں گے, اور یا جو ہے نا جس طرح میکینکس بیٹھے ہوئے اور شاپس میں. Don't expect any innovation, don't expect any inventions with these two mindsets. You need people, and I believe that these are scientists, mathematicians, these are technicians. Engineers should be here. If you are an engineer, do not place yourself in these two extremes, because they are both very dangerous. And because humanity needs engineers as well. Humanity cannot evolve with these two extremes.
Fundamental flaw in education.
Education system में ये fundamental flaw है कि we honor these both. We have competitions, best mathematician. Engineering university में math का competition हो रहा है. ये math की university तो नहीं है. फिर competitions हो रहे हैं robotics पे. I am not against these competitions. They are healthy. But it would be also encouraging to raise awareness. کیونکہ پھر کیا ہوگا, پھر پتہ ہے کیا ہوگا, پھر ہم صرف امپریس کرنے کے لیے, ایوارڈ جیتنے کے لیے ایکٹیویٹیز کرتے رہیں گے, اینڈ وی ول بی آلویز لوکنگ ٹو ویسٹ. اب آپ سوچیں نا, انڈیجنس تو کچھ بھی نہیں ہے نا. ہم جا کے بازار سے ایک چیز خرید لیتے ہیں, دوسرا خرید لیتے ہیں, پھر آپس میں ان کو جوڑتے ہیں, یا زیادہ سے زیادہ کوئی کوڈ لکھ لیں گے. سو فرام اسکریچ وی ڈونٹ ہیو اے سائنٹیفک کلچر. وہ کلچر کیوں نہیں آیا ابھی تک؟ We could blame politicians for that, we could blame the Americans for that, they are not letting us, but we are also to blame. ہم بھی تو ہم نے کبھی ٹرائی بھی نہیں کیا.
سر یہ جو ڈیفیکلٹ پارٹ آپ شیئر کر رہے تھے, ماڈلنگ یہ کچھ ڈیفیکلٹ پارٹ ہے, وہ نہیں لوگ کرتے.
نہیں, وہ ماڈلنگ اس لیے نہیں کرتے نا کیونکہ یہ دو ایکسٹریمز ہیں نا. To be in this extreme, you don't need these stages. So in our education system, we start a problem right here. X is equal to 2. Y is equal to 3. Find Z is equal to X square plus Y square. And we love this. So what will you do? Will you be waiting for some teacher? Will you call your teacher? Oh, I'm in industry. Please formulate a problem for me and send it to me. I mean, this is what we will be doing then. But we have this experience also. So I mean, it will take some time, but if we, the teachers, do not realize this, how can we expect our students to realize it? They are as good as we are. یہ مطلب اس میں ٹائم لگے گا میرے خیال میں, لیکن
The problem is basically that even teachers come and teach the students in the formal world. They start from the formal world and they end the formal world.
They end and they don't bother about interpretation and they don't bother about instruction. ٹھیک ہے, تو اور پھر یہ ہوتا ہے ہمارے پاس یہ چیز مسنگ ہے. پھر ہمارے پاس یہ دو کمیونٹیز ہے پاکستان میں. آپ کو یہاں پہ بیسٹ لوگ ملیں گے, اور ان دو میں یہ ہے بھی نا کہ یہاں پہ آپ یو کین ایکسل بیکاز یو I would say you disconnect yourself from the other side, you can actually excel. آپ دن رات میتھ کے بارے میں سوچتے جائیں, آپ دن رات آپ ٹیکنالوجی کے بارے میں سوچتے جائیں, آپ ایسے ایسے کام کر سکیں گے جو کہ باقی نہیں کر سکے گا کوئی بھی. ہو سکتا ہے کوئی بہت اچھا سائنٹسٹ بھی نہ کر سکے, کیونکہ he wants, the real scientist, the real engineer wants to make sense of everything. وہ پورے سسٹم کے بارے میں سوچتا ہے.
So the problem is we cannot do anything from scratch.
From scratch.
So ultimately,
تو وہ if we want to be independent, جو ہم اگر انڈیجنس کی بار بار ہم بات کرتے ہیں, اس کے لیے کلچر بھی چاہیے, سائنٹیفک کلچر. سائنٹیفک کلچر جو ہے نا وہ خود نہیں آئے. یہ کوئی اس طرح نہیں ہے کہ کوئی پارٹی آئے گی پولیٹیکل وہ کلچر لائے گی. We have to change ourselves. We have to change the way we perceive things. اور یہ بچوں سے ہم اسٹارٹ کریں پہلے. بچوں کو ہم صرف اس لیے اپریشیٹ نہ کریں کہ ان کے میتھ میں زیادہ نمبر آئے ہیں. اب دیکھ لیں آپ یہاں پہ کس 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 چیز کے کمپٹیشن ہو رہے ہیں. کبھی ہم نے کسی چائلڈ کو اس لیے اپریشیٹ کیا ہے کہ ہی انڈرسٹوڈ سم تھنگ. وی گیو زیرو ویلیو ٹو انڈرسٹینڈنگ. If something cannot be translated to an award or mark or grade, we just dismiss it. And this is the reason. تو پھر کیا ہوگا؟ پھر ہم شارٹ کٹس ڈھونڈنے لگیں گے کیونکہ ہمیں پتہ ہے کہ ہمیں صرف اپریشیشن ان میجرز میں ملے گی. یا وہ گریڈ ہوگا یا وہ کوئی ڈیمونسٹریشن ہوگی. تو ڈیمونسٹریشن کے لیے بھی ہم شارٹ کٹ ڈھونڈتے ہیں.
فی الحال تو ٹیک میں چل رہا ہے.
ٹھیک ہے نا؟ نہیں مطلب جہاں بھی چل رہا ہے نا وہ دوسرا ایکسٹریم بھی ہے.
میتھمیٹکس والی بھی
مطلب آپ کے پاس دونوں لوگ ہیں. یہ آپ مطلب آئی پرسنلی آبزرو بوتھ دیز ایکسٹریم.
میرے خیال میں مڈل والے تو کچھ یونیورسٹیز کے کورسز بھی مسنگ ہیں. درمیان میں کورسز بھی
ہاں ہے ہی نہیں نا. ہم دونوں چیزیں پڑھاتے ہیں. ہم ورک شاپ بھی پڑھاتے ہیں, لیب بھی ہوتے ہیں. آپ خود ہی دیکھیں فاسٹ میں لیب اور کورس کے درمیان کتنا کنیکشن ہے. لیب انجینئر اور ٹیچر کتنا ملتے ہیں ہفتے میں. And does the lab engineer care what is being taught in the class? Or does the teacher care how things are going in the lab? So blame is on both sides. کیونکہ ہم نے ان کو الگ الگ رکھا ہوا. یہ کلسٹر, اس کلسٹر سے ہم نے جان چھڑانا ہے if we want to be independent. تو یہ ایسے نہیں آئے گا باتوں سے. کوئی اور اس میں کوئی آبزرویشن؟
چلیے اویئرنیس خیال کریے.
وہ مطلب
نہیں چینج آہستہ آہستہ آئے گی. پہلے تو یہ ہے کہ ہمیں موسٹلی ہم فارمل ورلڈ میں ہی رہتے تھے. ہمیں آئیڈیا ہی نہیں تھا کہ کیا کنیکشن ہے اس کا ریئل ورلڈ کے ساتھ.
پھر اس کی کوئی ایک ایگزامپل آتی ہے آپ کے ذہن میں کوئی ایزی سی ہمارے ہم انڈرسٹینڈ کر سکیں کہ کوئی نیا پرابلم ہو ایسا جس کو اگر ہم یہ پروسیس سارا نہ کریں تو
بیسٹ ایگزامپل آپ کو راشد کریم دے سکتا ہے. آپ امیجن کریں جو ڈیوائس ماڈلز ہیں.
میری ایگزامپل الیکٹرانکس میں ہو سکتی ہے.
ہاں الیکٹرانکس کی ہو. وی آر الیکٹریکل انجینئر. کوئی آپ ذہن میں رکھیں, امیجن کریں کہ آپ یہ ماڈلز والا جو سین ہے نکال لیں. پی اسپائس کو بھی نکال لیں, کیڈلس کو بھی نکال لیں, وی ایچ ڈی ایل کو بھی نکال لیں.
پھر تو پاسبل نہیں ہوگا. فار ایگزامپل آئی سیز کے اندر کنیکشنز ہوتے ہیں تھرو میٹلز.
ٹھیک ہے.
تو ان میٹلز میں اگر یہ ماڈلز نکال دیں تو ہم اس کا ڈیلے کیلکولیٹ نہیں کر سکتے, کیونکہ آئی سیز کے اندر ہر جو ویز ہوتی ہے اس ویٹس کے مطابق اس میں آر سی ماڈلنگ کرنی پڑتی ہے. جب آر سی ماڈلنگ آپ کریں گے نہیں تو ڈیلے کیلکولیٹ کر ہی نہیں سکتے.
تو ڈیلے کیلکولیٹ نہیں کر سکتے
تو پھر وہ آئی سی آپ کی کمپلیٹ ہو نہیں سکتی, کیونکہ ٹائمنگ ویریشنز اس کے اندر اتنی آئے گی کہ آپ ایکسپیکٹ کیا کر رہے ہوں گے پریکٹیکلی کیا ہو رہا ہوگا.
نوٹس صاحب آپ کے ایگزامپل ذہن میں آ رہا ہے کمیونیکیشن یا سگنل پروسیسنگ میں؟ فرحان, ڈاکٹر فرحان بھی بتا سکتے ہیں مجھے. مطلب امیجن کریں کہ ہم یا اس میں سارا فوکس ہو یا اس میں ہو, یہ نکال دیں تو کیا گڑبڑ ہو جائے گی آپ کی فیلڈ میں؟
بالکل ہی گڑبڑ ہو جائے گی کہ ہم نے we have not done anything. We are not part of technological advancement in the first place. ہم نے کیا کیا وائرلیس میں, ہم نے کیا چیز بنائی ہے, کیا چیز ایکسپلین کی ہے. We have not done anything. So everything has been done in the West. West اب شفٹ ہو رہا ہے ایسٹ کی طرف پر.
وہ جاپان اور چائنا اور آ رہے ہیں بالکل.
میں بھی وہاں پہ پڑھا ہوں تو so I'm a product of the West also. So we don't have these things here.
آپ کیا سجیسٹ کیا کریں گے؟ کیا
if you remove anything then it cannot be realized. That's the thing. You have to model the real thing. Without modeling it, you cannot address the problems. You don't achieve the exact results, but you have a threshold. How close to the reality you can be. So that is the thing.
میں ایک
How
ایگزامپل
close to the ideal you can be. That's the same thing.
میں ایک ایگزامپل کوشش کروں گا کہ ایک سمپل ایگزامپل ہو کنٹرول کا. ٹھیک ہے, اور وہ کنکریٹ نہیں ہوگا لیکن وہاں پہ آپ کو آئیڈیا ہو جائے گا کہ وائی وی نیڈ دیز اسٹیپس. تو So let's say you are given a physical device, let's say motor, yeah? And you can replace this with refrigerator or air conditioner. ये एग्जांपल इसलिए भी ज़रा मुश्किल होगा कि हमारे सामने जितने भी मोटर्स हैं या रेफ्रिजरेटर्स या they already come with the control system in it. तो जो बात मैं डिस्कस करना चाहता हूँ वो ऑलरेडी उसका पार्ट है. लेकिन इमेजिन आप you could go back 50 or 60 years or 100 years जहाँ पे सिर्फ आपके पास वो हाइड्रोलिक या थर्मल या मैकेनिकल सेटअप है कि वो सिर्फ जो है ना वो आपको कोई चीज़ दे सकता है. सिर्फ मोटर जो है आपको स्पीड इट कैन रोटेट, ठीक है, या जो एयर कंडीशनर है वो आपको एक खास जो है ना वो टेम्परेचर दे सकता है. एंड लेट्स रिमूव द कंट्रोल सिस्टम फ्रॉम इट. तो फिर क्या होगा? आप इस डिवाइस को, आई विल कॉल इट अ प्लांट. प्लांट कुड बी एनीथिंग, मोटर और एनीथिंग एल्स. सो इसमें कुछ फीचर्स, कुछ क्वांटिटीज होंगी जो आप उसको चेंज करना चाहेंगे. लेट्स से इस केस में हम किस चीज़ में इंटरेस्टेड हैं? एयर कंडीशनिंग में, टेम्परेचर में. सो आउट ऑफ ऑल द अदर quantities, I choose temperature. This is my concern. So अब temperature का हम कोई desired profile देते हैं और हम जब press करते हैं तो what we want, if this is time, I want temperature to stay constant at that value, 24 degrees Celsius. But this is only one example. In a car, when you press the accelerator, you don't have this thing in mind. If this is speed, for example, if I replace this with speed, you don't want the speed to be constant, you want the speed to ramp up. So there the acceleration is constant. So you can think of many different desired behaviors. Now if you specify this either to an air conditioner or a car engine or any motor, there are now two ways. If you are in the tech community and you don't bother about models, what you will do, you will try to find out how can what are the handles which we call inputs through which I can get some output, temperature, speed. So that handle you say input. So in this case, in the air conditioning example, what do we need here?
Electricity.
Electricity आएगी उसमें. Electricity को हम use करके असल में हम we change the flow rate of something. So valve, it will be some valve opening. Depending on how, and that will then depend on electricity, power. So you will have voltages, currents, and so on. Motor case maybe it will boil down to electricity at some point, but there will be other processes. And you know transducers. Transducers translate electrical energy to the energy of your form. Like it could be a pneumatic, hydraulic system, thermal system. Now, if you do not bother about models, you will have to scan. It's like password hacking. If you want to hack a password, you have to think about all possible combinations. So you have to think about all possible inputs. And then you have to wait, and when you see that desired 24, you will say, okay, now. So I will do that now. Just imagine how difficult it would be. Because that may require some activity, and then for any other values, you have to repeat this whole thing again. So wouldn't it be nice? And why is it difficult? Because we are moving in the forward direction. And our specification is in the reverse direction. I want this value. Now that will be possible by a unique input. And it would be very nice and organized to find that input without doing any experiments, without waiting for months or years. I mean, in some cases it may not even be possible. Then you have to change the system. It's called controllability. If it is not controllable, you have to change the system. So you have to send it back to the engineers. Oh, I can't do anything with it. So if you now replace this thing with a computer model or mathematical model or simulation model, it will depend on how good you are in which area. Even building a model is not enough, because many people think that once I have a computer model, I will now, instead of doing all these things in the lab, I will now scan all the possible inputs and their behavior in software. Even that is not practical. It again is equivalent to that, analogous to the password hacking problem. So you should be able to relate the inputs with the outputs in the form of some rules, equations. Though those equations will be in some form, so could be algebraic equation, there could be differential equation, difference equation, different. I don't want to go into those details. And even writing those equations is not enough. From those equations, you have to bring those equations into some other form. For example, if I can bring this into some form of matrix, that this system can be represented as a matrix which operates on some vector. So this will be your input. And this gives you another vector, which is your output. Then all you need is to invert the matrix. If it is possible, it will not be possible all the time. Model inversion. So let's say this is possible. In some cases this is possible. So this model, let's say you can invert the model. And I will write -1 inversion. Now just see how this can change the situation. Now with the actual model, here is the input, which will be well opening or rect. Because you see it's turned off for a while and then on and then off and then off. You have a sequence because it has to maintain the temperature. Now here, the output is here, the temperature is here, so this is the unknown, that unknown input. But because this is the inverse, its input will be the temperature, opposite. So you can give that desired temperature here. And the calculations here will give you that right input. So you connect it to your model. You verify it, then you remove the model, bring in the actual system here. You remove the model, this is also a model, computer model. You will have to replace this with a microcontroller or a DSP or anything. So you have 2 blocks and you did it in one go. No hidden trial. Now, it is unfortunate that this approach does not work for many cases. Because this is mathematical inversion. Mathematical inversion is not possible. And I will give you one very basic example. Let's say that this model or this system is a delay. What that means is that anything at its input is delayed by 2 seconds at the output. Now you cannot undo that. You cannot go in future. So this strategy will fail there. There are many other examples you can think of. In that case, you forget about an inverse, and this strategy comes from our day-to-day examples. We are doing it all the time, and I'll illustrate it. So if you are asked to place, let's say if I want to place this marker exactly at this point, so what I will do, I will try and then see if it is ahead. So if it is ahead, then I will pull it back. But in pulling back, I can overdo this pulling, and then I go back. So after a few trials, I will be placing it. This is what you are doing in driving. Yeah? In driving, you look at if there is a vehicle coming towards you. At that point, you decide how to avoid it. So you are not doing you are not solving any mathematical equation. Adaptation. So all you are doing is feedback. You have some goal in mind, and you compare it with the actual situation, and then you take some action. So the controller is then very simple. In most cases, it can be a simple game. In some cases, integral or PID, all those stuff. You see, here you are indirectly inverting the model, but without any mathematics. And a very simple example. This is this may sound too technical. If I give you an example that is very simple, I mean, I don't think anything can be simpler than that. It is the flush system. Have you ever thought why water stops entering? I mean, when water is entering, at some point it stops. So there, if you have a tank and water is entering here, and let's imagine you have a ball here, which is somehow attached, and it can go up down. And if you want to maintain this level to some fixed value, and imagine the ball is initially here. Yeah? So now the actual level is below the desired level. So now, because the ball is here, water can enter, and then the level will go up, and then this will also go up. So after some time, what will happen? This ball will come here, and then it will stop the flow of water. So this feedback mechanism is achieved here simply by placing the ball. And this is, I mean, I don't know, whoever came up with this idea must be very genius. Because he didn't think about mathematics, he didn't think about equations. There are many other examples. That initial governor, have you heard governor? In power plants, you want to regulate the RPM of the turbine. Because if you can't maintain a constant speed, then the frequency in your AC circuits is directly connected with the RPM. So if the frequency changes, many things can go wrong. So how to ensure a constant speed? Yeah. And there the output is speed. The input there is also valve opening. You will have to regulate the input stream. If it's a hydel, you will have to change the flow rate of water. If it's steam. Yeah. So there, now it's done by computer control systems. But in the beginning, in industrial revolution, at that point they had a very simple mechanical device. So like two iron balls connected with a structure like that. You have two rods connected somehow to there was some sliding mechanism like piston. And now imagine these are rotating. So if the speed gets low, what will happen to these balls? This centrifugal effect. They will come down. And if the speed goes up, they will go up. And just these balls going up and down, they have this negative feedback mechanism. It will now regulate the flow of water. See here, no mathematics. So now, of course, this is now in a museum, but just imagine how genius this idea was. So this is just to illustrate that, I mean, all this will not be possible without models. Yes?
एक सिंपल एग्जांपल मेरे ध्यान में है सर इसको मुझे एक्सप्लेन करेंगे वेलनेस मेडिकेशन
Wireless.
वायरलेस कम्युनिकेशन के अंदर चैनल मॉडलिंग,
ठीक है।
जब तक आप चैनल को मॉडल नहीं करेंगे तो आप
उसको compensate करेंगे।
कंपनसेट नहीं कर सकते।
प्री कोडिंग और पोस्ट कोडिंग,
चैनल इक्वलाइजर फॉर एग्जांपल,
चैनल इक्वलाइजर, बिल्कुल।
अगर मतलब मॉडलिंग ना करें तो फिर मेरे ख्याल में टेली कम्युनिकेशन, वायरलेस कम्युनिकेशन पॉसिबल ही नहीं है। आप सिग्नल वहाँ पे
एरर्स
जो चैनल आपके सिग्नल के साथ कर रहा है, आपको अगर वो पता ही नहीं है,
हाँ,
तो
फिर
आप
तो
उसको
proceed नहीं कर सकते।
अंडू कैसे करोगे? अंडू तो तब करोगे ना, और वो एक्सपेरिमेंटेशन से तो नहीं होगा। एक्सपेरिमेंटेशन उसमें आएगी, लेकिन यू विल हैव टू रिपीट मेनी एक्सपेरिमेंट्स एंड देन कंसोलिडेट ऑल दैट डाटा इनटू अ मॉडल।
लेकिन चैनल भी तो चेंज होता रहता है ना, विद द पैसेज ऑफ टाइम वहाँ पे कोई और सिचुएशन अराइज हो जाए।
नहीं, चैनल फिक्स नहीं होता था। हाँ,
चेंज होता रहता है ना विद द पैसेज ऑफ
Reading
लेकिन
के
डिजाइन
model दें आपको fix हो
सर
जाएगा।
मूवमेंट लेंगे डिजाइन के लिए आप जो है
क्या लेंगे?
आप उसको मोबाइल कर वेरिएशन,
अच्छा, ठीक है।
उससे के वेरिएशन
Mobile
कम्युनिकेशन के हद तक तो ठीक है, लेकिन if you are मोबाइल
तो उसमें फिर चैनल भी चेंज होता है।
नहीं, मोबाइल ना हो, स्टैटिक हो,
फिर?
स्टैटिक में
it will change.
अच्छा, स्टिल नहीं तो उसकी कोई है रीजन?
कम्युनिकेशन
क्योंकि ऑब्जेक्ट्स मूव कर रहे हैं अराउंड, सो इट इज नॉट
हमसे
जस्ट
आपको जो मिलते हैं
अच्छा।
बाउंस होके
तो जो आज अगर हम कॉपर वायर्स या ऑप्टिकल फाइबर्स की बात करें, वो तो चेंज नहीं होता। तो मतलब ये मसला वायरलेस में है।
नहीं, वो फिर एडेप्टिव की जो आप बात कर रहे थे ना,
अच्छा।
एडेप्टिव चैनल इक्वलाइजेशन होता है।
लेकिन ये कि हम वेरिएशंस को बहुत मिनिमम लेवल पे रखते हैं, दे आर नॉट सो सीवियर कि जिसकी वजह से आपको बहुत बड़ी चेंज लानी पड़ेगी आगे सिस्टम के अंदर।
सही है।
वो तो फिर मॉडलिंग मेरे ख्याल में कंजेस्टेड जो जगह है उन पे डिफरेंट होती होगी, कुछ जगह डिफरेंट।
अच्छा, ये जो मतलब इन्होंने अभी डिस्कशन शुरू की है ना, हाँ, इनने डिस्कशन शुरू की, ये और फिर उसका नेक्स्ट लेवल है। इसमें ये है कि वन मॉडल विल नॉट वर्क, you will need many models or you will have to model at run time.
डिपेंडिंग
हो सकता है उसी टाइम पे आपको मॉडल अपडेट करना पड़े।
डिपेंडिंग ऑन द सिनेरियो।
तो एडाप्टिव कंट्रोल या एडाप्टिव फिल्टर्स में यही होता है कि उसी टाइम पे मॉडल यू विल हैव टू अपडेट योर मॉडल।
तो ये फीडबैक वाला वही आपने
हाँ, बिल्कुल उसमें भी फीडबैक आएगा।
अक्सर इसको आप जो कह रहे थे ना ग्रास रूट लेवल से शुरू करना है, तो उसके लिए कोई दो स्टेप्स को बताएं ना। मतलब बच्चों में क्यूरियोसिटी को हम दबा देते हैं, वो भी एक पॉइंट है इसके अंदर। बस ये इसी तरह है जिस तरह हमें टीचर से जवाब मिला था।
आप मैंने से शुरू में बात की थी ढूंढने के, उस टाइम आप आए थे। अच्छा, उस टाइम की मैंने उसमें एक सजेशन ये दी थी कि हम बच्चों को अप्रिशिएट करें सिर्फ एक टाइप की एक्टिविटी पे ना, कि उनके कितने ग्रेड्स आए हैं, उसको कितना अवार्ड मिला है, कौन सा अवार्ड मिला है। हम उसको अंडरस्टैंडिंग पे भी अप्रिशिएट करना शुरू करें कि आज जो है ना इसको ये चीज़ समझ आई है, ठीक है ना। तो वाह फैक्टर जो है ना उसमें होना चाहिए, क्योंकि जब ये नहीं होगा ना तो एवरी चाइल्ड विल बी लुकिंग फॉर शॉर्टकट्स टू गेट अप्रिसिएशन। ये ह्यूमन नेचर है, वी आर लुकिंग फॉर अप्रिसिएशन। तो इफ यू डोंट अप्रिशिएट फॉर द राइट रीजन, यू आर एक्चुअली कोयर्सिंग देम to go for shortcuts. तो उसमें हमारा रोल है, उनको हम ब्लेम नहीं कर सकते।
मैं उसकी एक एग्जांपल देता हूँ ना कि कल मेरे बच्चे का रिजल्ट आया, अब वो उसके मैक्सिमम मार्क्स हैं अपनी क्लास में, लेकिन ओवरऑल सारे सेक्शंस में नहीं है। तब वो उसकी मामा उसको ये कह रही हैं कि हमें तो सारे सेक्शंस में से मैक्सिमम चाहिए मार्क्स। ठीक है, तो मार्क्स ही वो एक है
मेजर हमने बता दिया ना, तो अब वो मेजर को अचीव करने के लिए वो कुछ भी कर सकता है। वो उसमें ये तो शॉर्टकट वाली बात तो आनी है। कंपटीशन का जो सेंस आता है कि उसी टाइम से वो दोस्तों के साथ जो है ना वो वहाँ पे ये हो सकता है कि ठीक है इसको जो है ना लगाओ इन एक्टिविटीज में, पढ़ाई करना शुरू करो। ये नेगेटिव सारी जो टैक्टिक्स है ना, ये दिस इज एक्चुअली ड्रिवन बाय कंपटीशन। अगर आप उस चीज को उस टाइम पे लिफ्ट नहीं देंगे तो वो फिर पॉजिटिवली सोचेगा आप चीज के बारे में। नोट्स छुपाना दोस्तों क्लास फिर उससे
बिल्कुल।
ये कहाँ से आता है?
और हमारी थॉट भी नहीं जाती किसी नए प्रॉब्लम को टैकल करने के लिए, इसका इतना खौफ होता है हमारे जहन में, क्योंकि हम मॉडलिंग से वाकिफ नहीं है ना, एब्स्ट्रैक्शन और ये चीज़ आती नहीं है। तो प्रोजेक्ट जब पिक करने की बारी आती है तो हम प्रोजेक्ट्स फिर वो ऐसे पिक नहीं करते जहाँ पे एब्स्ट्रैक्शन इन्वॉल्व हो।
वो हमें पता है कि ये हमें तंग करेगा।
हाँ
تو ڈے ون سے ہم ایسا پروجیکٹ چوز کرتے ہیں جس میں یہ ڈرامہ بازیاں نہ ہوں. آپ کا کیا ایکسپیرینس ہے اس بارے میں؟ آپ کافی لیبس میں انوالو رہے ہیں نا.
جیسے شروع میں آپ نے ایک بات کی تھی نا کہ ریالٹی جو ہوتی ہے نا اس سے ایک پرسیپشن ہوتی ہے
بالکل
کہ ریئل ورلڈ ہے اور اس میں کنسیپچل ورلڈ میں ہم نے اس کے کچھ ماڈلز بنائے ہیں.
ٹھیک ہے.
تو اس کی ایگزامپل مجھے یاد آئی تھی کہ جب ارلی 1700s میں جب برٹش جو تھے نارتھ امریکہ جا رہے تھے نا کانکر کرنے, تو وہاں جو نیٹیوز لوگ تھے انہوں نے کبھی کوئی بڑی شپ نہیں دیکھی تھی. ان کے پاس چھوٹی چھوٹی کشتیاں ہوتی تھیں, چھوٹی چھوٹی اپنے وہ ہوتے تھے. تو جب ان کا بڑا شپ آ رہا تھا نا انہوں نے اس کو ایسے اگنور کیا کہ جیسے یہ ہے ہی نہیں. وہ بڑی شپ آتی رہی, وہ اپنا کام کرتے رہے, کھیتی باڑی کرتے رہے, رات کو سوتے رہے, جاگتے رہے. پھر جب اونلی ایٹ اے ٹائم جب انہوں نے اپنی چھوٹی شپس نکالی نا اور وہ ان لینڈ رو کرنا شروع ہوئے, پھر انہوں نے ریلائز کیا کہ یہ انویڈر ہے, اور پھر انہوں نے اپنے ہتھیار نکالے اور لڑائی شروع کی. اس میں انہوں نے یہ کہا تھا کہ ان کی جو کنسیپچل ورلڈ تھی اس میں بڑی شپ جو تھی اسی طرح تھی, کوئی سورج اٹھ رہا ہے, جا رہا ہے, مون ہے,
اور نیچر کی کافی چیزیں ہو رہی ہیں ہونے دیں.
انہوں نے بڑی شپ ہے, اس کا ہمارے سے کوئی لینا دینا نہیں, آ رہی ہے کوئی بات نہیں, آنے دیں. کیونکہ ان کے ذہن میں صرف چھوٹی شپ کا
جیسے کلاؤڈز آ رہے ہیں نا.
ہاں بالکل.
کلاؤڈ نے مجھے کیا کہنا ہے,
تو برٹش کے صاحب جو ان کا ایڈمرل تھا اس نے کہا کہ ہم نا 2-3 دن ویٹ کرتے رہے کہ ہمیں اٹیک کیوں نہیں کر رہے لوگ. تو وہ آرام سے انہوں نے ہم سے اگنور کیا, کوئی دیکھتا بھی نہیں تھا, اپنے پاس دن اٹھتے رہے,
یہ بیسٹ ایگزامپل ہے آئی تھنک.
رات کو سو گئے. کہتا پھر آن دی جب ہم نے اپنی چھوٹی شپس نکالی ہیں نا, جو چھوٹی رو بوٹس ہوتی ہیں, پھر وہ اندر ان لینڈ جانے لگے, پھر انہوں نے ہمیں اٹیک کیا, کیونکہ وہ ان کے ذہن سے چھوٹی شپ کا کنسیپچل ماڈل تھا. بڑی شپ انہوں نے کبھی دیکھی نہیں تھی, تو ماڈل نہیں تھا ان کے ذہن میں.
میرے خیال میں اس سے ریلیٹڈ میں نے ایک اور بات بھی سنی تھی کہ یہ ان کو جب انہوں نے کہانی سنائی یہ آئس کی, تو دے ور لافنگ, انہوں نے کبھی آئس نہیں دیکھی تھی نا, تو وہ کہہ رہے تھے کہ یہ شاید ہمارے ساتھ مذاق کر رہے ہیں.
آپ بھی تو نہیں کر رہے اتنی دیر
برف.
اصل میں ایکسٹریم آپ کی پاسبلٹی کا بھی تو ایک ڈسٹریبیوشن ہوتی ہے نا. اب فار ایگزامپل میں انہیں بتا رہا ہوں کہ 4.5 وولٹ ہم ایکسپیکٹ کرتے ہیں, تو اس کی کیا پروبیبلٹی ہے کہ 100 وولٹ ہم میئر کر لیں. ہم کو سمجھ ہی نہیں آ رہی کہ 100 میں پوچھ ہی کیوں رہا ہوں, 4.5 میں آس پاس کی وولٹیج ہی آئے گی نا. تو ایکسٹریم کی ایگزامپل ہمیشہ آؤٹ آف اسپیکٹرم ہوتی ہے.
آؤٹ آف اسپیکٹرم ہوتی ہے.
مطلب اس کی بہت ساری ایگزامپل ہسٹری میں موجود ہیں جیسے بتا رہا ہے.
بالکل ٹھیک ہے, پھر وقت ہو گیا. تھینک یو.
لیکن آپ نے ڈاکٹر سعید والے بات کا جواب ایک بنتا ہے.
ڈاکٹر سعید والا جواب آپ دے دیں.
آپ ایکشن آئٹمس ڈیفائن کریں گے.
ایکشن آئٹمس تو یہ ہے کہ میرے خیال میں جو ایگزسٹنگ ایجوکیشن سسٹم ہے اس میں ہمیں اپنا کوئی لانچ کرنا پڑے گا, اپنا سسٹم ہم ریلائی نہیں کر سکتے. وی کی ناٹ کنونس دی اونرز آف اسکول.
دی کرنٹ سسٹم
وہ نہیں کر, ان کا اپنا انٹرسٹ ہے نا. وہ اسٹیٹس کو جو چیز چل رہی ہے وہ ٹھیک ہے, کیونکہ اس میں اس قسم کی چینجز میں انڈر شوٹ آتا ہے. وہ انڈر شوٹ کوئی بھی آن نہیں کرے گا. سو وی ہیو ٹو ٹیک دیٹ فرسٹ اسٹیپ. We will be knowing that we can go through a
آپ کے ذہن میں وہ سینئر ٹیچرز ہیں کہ وہ نیا سسٹم کیسا ہوگا, اس میں کیا شارٹ کمنگز ہیں, وہاں ہم نہیں کریں گے. یہ کسی اور سیٹنگ میں اگر آپ بتانا
وہ ہم بتائیں گے انشاءاللہ. وہ میں اس کے بارے میں بھی سوچوں گا. ہاں, یہ چیز انکلکیٹ کرنے کے لیے کیا کیا ہمیں اسٹیپس چاہیے. I have never thought about that in detail, so یہ انشاءاللہ ہم پھر نیکسٹ اس میں کریں گے.
وہ بات پھر وہی رہے گی. ابھی ہم کیا کریں سر؟
ابھی ہم کیا کریں
سر, ہم کی کریے نا, اگر بچے آئے نا لگی کریے. سر ایک طریقہ کا یہ ہو سکتا ہے کہ کوئی بھی چیز جو آپ ان کو بتانے جا رہے ہیں, آپ یہاں پر اکثر اس طرح کرتے ہیں, یا شاید میں کوئی اور بات کروں, کیا پرابلم بتا دیتے ہیں ان کو یہ کہ ہم دسو کی کریے, بجائے اس کے کہ بس شروع کر دیا وہاں سے لے کے آخر تک کر دیا, آخر میں اے لکھ کے دھیان سے. اس کے بجائے ان کو انوالو کیا جائے, ڈالا جائے اس کام میں کہ
انٹریکٹیو.
ہاں جی
انٹریکٹیو.
ہاں
یہ تو
کریں کیا, تو ان کو تھوڑا سا سوچنے پہ مجبور کیا جائے. پھر اس میں ہو سکتا ہے کچھ حد تک یہ چیز کور ہو جائے.
لیکن پرابلم یہ ہے نا کہ جو یہاں پہ جو میرا فوکس اس جگہ پہ تھا وہ مینلی ٹیچرس پہ تھا, اسٹوڈنٹس پہ نہیں تھا. کیونکہ ٹیچرس اسٹوڈنٹس ڈیپینڈ آن ٹیچر. تو ٹیچرس کے ہم مطلب لیے میں ایک ریکویسٹ میری یہ تھی کہ آپ جو ہے نا اپنی ٹیچنگ اسٹائل میں یہ چیزیں انکارپوریٹ کریں, کیونکہ اگر ٹیچر کسی چیز کو امپورٹنس دے رہا ہے تو اسٹوڈنٹ تب امپورٹنس دے گا. ٹیچر نہیں دے گا تو اسٹوڈنٹ اپنی طرف سے امپورٹنس نہیں دے گا. ابھی جو آپ دوسری بات کر رہے ہیں ایز اے سوسائٹی, وہ اس کے لیے وی ہیو ٹو اسٹارٹ مچ ارلیئر ایٹ اسکول لیول. یہاں تک آتے کافی بگاڑ ہو جاتا ہے. تو اسکول لیول پہ جو ہے نا ہمیں کوئی ایسا سسٹم انٹروڈیوس کرنا پڑے گا شارٹ اسکیل پہ کہ اس میں میجرز ڈفرینٹ ہوں. وی ہیو ٹو چینج دا میجرز آل دیم. جب تک یہ ایگزسٹنگ میجرز ہوں گے تب تک جو ہے نا وہ ان کو اچیو کریں گے. اچیو کرنے کے لیے وہ شارٹ کٹس پہ جائیں گے, اور شارٹ کٹ روٹ لرننگ ہے. روٹ لرننگ شارٹ کٹ ہے, اس میں آپ کو انڈرسٹینڈنگ آپ کی دماغ پہ زیادہ زور نہیں لگانا پڑتا. ٹھیک ہے,
نیکسٹ ویک ہوگی. نیکسٹ ویک ہوگی.
نیکسٹ ویک تو ہوپفلی ہوگی.
نیکسٹ ویک ہوگا لیکن